Hello friends, welcome to Booty Aviation Training. And today we are going to study a lesson in meteorology, classification of winds. The three playlists are already running: navigation numericals, L1, L2, etc., meteorology lessons M1, M2, M3, etc., and technical tidbits, answers to commonly asked technical questions T1, T2, etc. And today, let us study about winds. Now, you'll be surprised that even winds have different names. They are classified by their names. Wind is a wind. Okay. And why is this classification done? We'll read little later. And what is a wind? Air in horizontal motion. And air in vertical motion is called turbulence. In horizontal motion, wind, the air moves from one place to another, from an area of higher pressure to an area of lower pressure. And the wind direction and the speed depends upon these following forces. Number one, there must be pressure gradient. The winds always go from a high towards the neighboring low pressure area, and the rate of fall of pressure is called horizontal fall, is called pressure gradient. Now, like here you see there is a hill, and if there is a heavy rainfall over here, the rain will always move towards the lower direction, towards the plains, and the direction in which the gradient is mild, slow, less, the speed will be less, and where the gradient is sharp, subtle change of height, and that is the side in which the speed of the water will be more. So the speed of the winds depends upon the pressure gradient. Here you find pressure gradient is high, and here it is light. Coriolis second is, as far as the direction is concerned, the Coriolis force has an effect in the change of direction from high to low, also called geostrophic force, and which is due to rotation of the earth. The atmosphere rotates with the earth. Third is a force called cyclostrophic force, predominant in depressions, deep depression, where all the winds are just being pulled inside, and the pressure gradient force becomes the cyclostrophic force. We measure the pressure gradient force at 90 degrees to the isobars, and the wind speed will be proportional to the pressure gradient. Direction will be always high to low and modified by the Coriolis force. Now, Coriolis force, also called geostrophic force, deflects the winds going from high to low towards right in the northern hemisphere and left in the southern hemisphere. Who told us? Fresnel's law. The magnitude of Coriolis force depends upon the air density, wind speed, angular velocity of the earth, known as omega, and the latitude of the place. And where is the sign of the latitude? Coriolis force is maximum near the pole and nil at equator. At equator, winds just travel from high to low. They are not deflected to left or right. Then a gentleman called Biabalet, he told us that if you stand your back to the wind, in the northern hemisphere, the low pressure will be to your left. And in the southern hemisphere, it will be to the right. He could ask you standing with the back to the wind. He could say standing with the back to the low, standing with back to the high, which side does it be? Just understand this one diagram. This is for the northern hemisphere. Person is standing with the back to wind. That means the wind is from this side to this side. The winds going from a high towards low are getting deflected towards right. And as you go towards low, the wind speed will also gradually increase. And near the low, now the winds will be drawn inside the low pressure area. So this is Bye-Bellet's law. Right. Next, a few common questions asked from this lesson. Based on the forces which are active, the wind is identified by different names. Geostrophic wind. It is due to the pressure gradient force plus the Coriolis force. So when the isobars are straight and equidistant, the wind flow is parallel to isobars. Near the high pressure and low pressure area, the geostrophic wind becomes gradient wind because cyclostrophic force is also acting now. So pressure gradient plus Coriolis plus cyclostrophic force combined, that wind is known as a gradient wind. And in a intense depression, winds are moving only inwards towards center from all sides. And the pressure gradient force has now become cyclostrophic force, and those winds in the depression are known as, or cyclone, are known as cyclostrophic winds. Thermal wind is due to temperature difference between the two areas. At the ground level, colder areas will have a higher pressure compared to the warmer areas. Now the pressure lapse in a cold air mass will also be higher. Therefore, at high altitude, the pressure over a cold area will become low, and over a warm area it will become higher, and thus setting up reversal in wind directions. That wind is known as thermal wind. The reason is thermal gradient. Now, geostrophic wind flows parallel to isobars. The thermal wind flows parallel to the isotherms. Then there are local winds, particular regions. In the hilly regions, during the daytime, the hill slopes get heated up, and the wind coming in contact with the hill slopes becomes lighter, heated up, lighter, and starts rising, ascending, called anabatic winds. During night, this wind near the hilltop becomes cold and heavier and flows downslope due to gravity and called katabatic winds. Then there is land and sea breeze in coastal areas during daytime. The land gets heated up more than the sea, and thereby creating a lower pressure area over the land, and the sea breeze, that is from sea to the land, the wind direction starts, and reverse happens at night, and the breeze blows from the land towards sea midnight and early mornings, called land breeze. And here you are, some more to go. Slightly long lesson, keep with me. But at the same time, let me remind you, there are a number of questions contained in this. Every line that I'm telling you now, please remember it carefully, and you might find it as one of the questions in your examinations. What is the daily or the diurnal variation within a period of 24 hours with other factors, pressure, temperature, etc. remaining same? What is the diurnal variation during day? The winds were in northern hemisphere and back in southern hemisphere and increase in strength in both hemispheres. What is veering of the wind? Clockwise change of wind direction is called veering, and anti-clockwise change of direction is called backing. During night, the winds back in northern hemisphere and veer in southern hemisphere and lull, that is decrease in strength in both hemispheres. The surface wind direction reported to the pilots for the landing is reported in direction magnetic on RT or ATIS, whereas upper level winds given to you in the map forecast for the flight planning or the METAR or the TAF, etc. are true in direction. The runway directions are magnetic, so the surface wind is also magnetic, so that the pilot can calculate the crosswind component, right? The way to remember is wind direction which you hear, okay, is magnetic, and the wind direction which you read in your forecast, etc., is true. What you hear is on the RT, it is magnetic. Now, surface winds direction is measured by an instrument called wind vane and speed by the cup generator or a pressure type anemometer. Both are placed 10 meters, roughly 33 feet to be exact, above ground level. Lines joining places of equal wind speeds on your charts are called isotax. Now, if need be, go through this lesson 2 to 3 times till you grasp it fully. Can't afford to ignore this lesson, although slightly long, but then you are going to get marks for every question answered correctly. And now, before we say bye-bye, there is some points or a reminder. Now, wishing you happy landings, keep smiling and make new friends by sharing the channel link. And of course, a reminder, before you log out, spare some time, subscribe, like, and press the bell icon, remain in touch, and lot more coming up from yours truly, SK Booty. It's over only for the day and shall see you soon with the next lesson. Good luck. Bye-bye.